All right, continuing our discussion about the ICE lab, I'm going to talk about the hypothesis, materials, as well as the procedures in this short little video clip. Let's start talking about the hypothesis. What's going to be a little bit different than the previous two labs is the fact that Mr. Fuzak and I are going to put it on you and or your partner to come up with your hypothesis. Now, the hypothesis, I mean, literally, you could come up with a lot of different things, but keep in mind that you are testing whether or not ice is going to melt faster in salt water or ice is going to melt faster in regular tap water without salt. So keeping that in mind, if that's what the actual lab is about, that's what you should aim your hypothesis to be about. You know, but when doing this, you must include the if, then, and because statement for your hypothesis. So, whichever one you believe is going to be the one to melt fastest, with salt or without salt, you need to then put it into a statement that states, if this happens, then here's the reason why, because, and here's our data to support it, or our reason for it. The next step are the materials. The materials is kind of an extensive list about the things that we have available for you to use. And what I want to make very clear to you is that if you would like something different, if you want a different material, something that Mr. Fuzak and I have not provided for you, then simply ask. What I will tell you is, if we've got it, you're more than welcome to use it. And if we don't, then the fact is we just don't have it, and you're going to have to just come up with something else. Or maybe if you want to bring it in from home. But the fact is that what we have available for you is plenty and ample, and that should definitely give you all the results that you will need to perform this actual experiment. So here's what you will find with the materials. All right, here are your materials that you're going to have available for the ice lab. In one of these two buckets, you will find water and ice. So in one of those, you'll have salt. You'll have a cup in which you can use for measuring your water supply and also performing the experiment. You'll have a spoon in which you may or may not use for stirring. You'll have different sized gradual cylinders, and the reason why you'll have different types is because depending on the amount of materials that you're going to use. You'll have different types of balances, again, depending on your preference. You may or may not even need them. So these are the materials that we will supply for you. If there are any other materials that you would like that are not already provided for you, just ask for them and we can see if we have them for you. About is going to be the actual procedures. In your two previous labs, you've had the opportunity to basically go step by step through a lab, just simply following and reading procedures. Now what we're going to ask of you is to simply create your own for the lab in which you're going to perform. So my suggestion to everybody is going to be the following, is that go back and look at your inquiry lab procedures from the lab that we just completed, or even go back to the Diet Coke and Mentos lab. And that will help to give you some ideas about the order and procedure steps that are needed to complete an actual experiment. So the first thing I'll point out to you is this, like we have stressed again and again, is that you need to number them. Step number 1, step number 2, 3, so on and so forth. Second part, I can almost guarantee you that there's absolutely no way for you to complete this experiment in under 10 steps. Now, this is not me challenging you. This is me being very honest and saying that when writing a lab report, especially when writing procedures, you need to be very clear, very concise, and you need to include details. But you don't want to include too many details on just one procedure step. One step equals one. So, step number 1, fill the cup up with 10 cubes of ice. Step number 2, add 250 mils of water. Step number 3, whatever else you need to do. But the fact is, you notice that there's only one thing that you're being asked to do per step. So that's why, you know, a need for at least 10 steps is very important. But most likely you're going to have more steps than 10 most likely you're going to have somewhere in the upwards of 20 or plus more steps. And then the last thing that happens, you're going to repeat things. You've performed a task. You've actually added ice, you've added water, you've done a number of different things. So it's very common for people to say, once you've done something completely, repeat steps 1 through 15 for trial number 2, and then record it in your data table. So make sure, you are more than welcome to say that you need to go back and repeat steps, and I apologize for the fly that keeps buzzing my face. But at the same token, you need to pick out where you're going to say repeat steps, whatever. So be very clear about that. And remember, 1 procedure step equals 1 action. Do not put 2 or 3 or more actions per step. Only 1 step equals 1 action.